Alright, good morning or good afternoon, scholars. This is Mr. Who from Heron, and today we're going to be doing our first skill for the semester of Algebra 2 Semester 2. That is, of course, parent functions. So we've got two objectives to get to today. That is to be able to discover the general shape of a variety of functions, a total of 7 today, as well as to use function knowledge to determine what function family a particular function belongs to. So that's how to identify the parent function from a group of different functions. All right, and we also have the agenda for the class on Thursday and Friday. Hopefully that was explained to you in the I guess we call it syllabus day, but it's really just a getting to know you day, and we'll work through it. All right, so let's go ahead and get started. Let's go ahead and get started with the lesson here. We're talking about parent functions, of course, but we need to define two key phrases that we're going to be using to describe parent functions. So the first of these is function families, right? That is, of course, a group of functions here. We'll define it in a sec, so you can write it down in your notes. And parent functions, which of course is our goal for the day, the lesson. So let's go ahead and put the definitions up on screen here. So first of all, function families. When I'm talking about a function family, I'm talking about a group of functions that have the same shape. Okay. Things like lines, parabolas, circles even, ovals, okay, or ellipses as we call them in the math world. Those all have functions that would, let you graph those, but those functions are all very similar. So we call them function families, right? And of course, a parent in a family is usually the eldest, okay, at least in the immediate family. And so the parent function is the most basic function in the function family, right? So if I'm talking about a line, then of course the parent function for that family will be a line, right? Same thing with the quadratic, the parabola, and all that other good stuff. So let's go ahead and talk about two more things we need to get to before we get to the actual parent functions. That is, of course, domain and range. You've probably heard these terms before. You probably have a vague understanding of what those are. I'm not going to be focusing too much on these things. We'll cover it a little more in class. So domain and range, put simply, are just all the x's or all the y's, depending on which one you're talking about. So domain, all the x's in a function. If you remember, x is the horizontal axis, so it'll be all of the left to right, or I guess it'll be left to right here for you guys, functions, function values. Whereas range is a list of all the y's. Y is vertical, so all the functions values from up and down, that's all the y's. Okay. Again, we're not going to cover them too deep, so if you still aren't sure, just jot it down. We'll talk about it in class a little more. All right. So let's get to our first function family and our first parent function. So the first parent function here is going to be y equals x. Okay, y equals x. Now, if you remember from your Algebra 1, okay, we did a lot of work with this kind of function. This is the linear function. Okay, linear function. All right, so this is a line, of course. And if you remember what the base form of this looks like, okay, it's just infinitely going on forever and ever, line, okay? And this is what it looks like, all right? Try to make it go through the middle there as much as possible, okay? That is our parent function. Now, there is a table to the left, I know, but I'm not going to be using it because of time constraints and because, well, I feel like you guys can plug in values for a function, and if you, don't know if you're really that good in it, we can always meet and talk about it later. So this is our linear parent function. It does have a domain and a range. Okay, those arrows indicate it goes on forever in both those directions, right? And so if I think about all the x's I can list forever and ever, it should be all real numbers. Okay. As well as for range, range is also unlimited here. Okay, it keeps going up and down, so all real numbers it is for this one as well. Okay, so that is our linear parent function. Really simple stuff. Okay, I'm sure you didn't need me to tell you that, but let's move on to the next parent function. How about it? All right, so for this one, we're looking at y equals x squared. You've probably worked with this one as well. Okay, you maybe even remember the name for it. The name is quadratic. Okay, quadratic. Sorry for the little Scrabble. I'm still getting used to this pen tablet, so hopefully I can get better at that over time. Okay, now, if you remember what a type of form the quadratic function takes, it is, of course, that of a parabola. All right, so we're starting on 0 here, 0, 0, and our quadratic, get it to work, will look something like this. Okay. Not a perfect drawing by me, okay? You also don't have to be perfect in your drawing. If you really are worried about that perfect, I have to hit the points, okay? You can always look on the table on something like Desmos or a graphing calculator or something like that to get a better drawing. But for the most part, this will suffice, okay? And unlike the linear function, you can see that none of the values in quadrant 3 or 4 are connected with, right? So that will change what our domain and range will be. It does, however, have the same domain as the linear function. It is still all real numbers. Okay, all real numbers. It might look deceptive, but this axis will go on forever to the left and forever to the right and forever up. Okay, so no matter what x you pick, there will be a y value. Okay, so we know it's defined, and the range, of course, doesn't actually go below. So this would be y has to be greater than or equal to 0. Okay. Alrighty then. Let's continue moving on here to our next function. That would be y equals x cubed. All right. So we're just adding on a little more exponents here and there. Okay. If you follow the pattern so far, you might even know what this is called. This is called the cubic function. Oh, that is a terrible U. Let me try and fix it. There we go. Cubic function. Okay. So cubic functions, they look a little funky. Okay. They're more of the squiggly form I was talking about. Again, you still have to start on 0, 0, if I can hit it right. There we go. Okay. But the form they take is more of like one side parabola and the other side goes the other direction. Okay. So this is kind of the general form for a cubic, right? Again, not perfect. If you are very picky about that, go into the Desmos and figure that out for yourself, okay? Now the domain, again, is still going to be all real numbers. You might see a pattern starting here, okay? But soon we'll be changing that in the next couple, all right? The range is also kind of like that of a line. It goes up and down, so this is all real numbers as well. Okay, all real numbers as well. All right. So far, so good. You probably have seen all of these before in some capacity, so let's continue moving on to the next one. This is the next function. You may remember these bar-looking things, these bars, okay? The function itself is not spitting any bars, but you can kind of imagine it is, right? There's no harm in that. And those bars represent absolute value. So that is the type of function we're talking about here. Okay, absolute value function. Okay, if you recall what that looks like from a previous class, it's very simple. Okay, you've got a 0, 0 point. Okay, the right side looks like the linear. Okay, goes shooting off into the upper right. Okay, but if you remember what absolute value describes, it turns anything inside of it positive. So it has a right side that makes the whole thing look like a V together. Okay, V for absolute value. Now, the domain and range, okay, are going to be similar to that of a parabola, okay? So if you remember from that, you can even be filling this in on your own. But it's going to be all real numbers for the domain, okay? And y greater than or equal to 0 for the range, okay? Because it doesn't go below the x-axis, so you can't actually have any negative y's, right? All right, so that one was pretty simple as well, okay? So far, so good. We're still doing the simple stuff. Now we're moving on into the harder stuff, though. So this one's definitely one of the harder ones you might look at over your math career. This is y equals 1 over x, with x in the denominator. Okay. So when we talk about this function, we're going to be calling it the rational. I'm going to zoom in a little bit. Rational function. Okay. We'll zoom out. All right. The rational function, okay, is this group of functions that is kind of separated, okay, and I'll show you why. Okay. Let's think about this. If you put x equals 0, what will happen to your y? Well, you can't divide by 0. So if you put x as 0 in this parent function, well, the graph just doesn't have a point to put it at, right? So we can't actually put any points at 0, 0. Okay. But if you fill out the chart, as long as you go on to Desmos or something like that, you can find the shape to be something along the lines of this. You've got one leg, or I guess smiley face, in the top right. Okay, and then you've got a little bit of a frowny face in the bottom left. Okay, so this is the general shape of the rational function. Okay, and it's all because of that pesky x in the denominator. You can't make x equal 0 if it's in the denominator because you can't divide by 0. So that means we don't even have a 0 here. What does that mean for domain and range? Well, we can't have 0 at all. So we have to say that x is either greater than 0, okay, or it has to be less than 0, okay? So you have to have two of these things saying that, all right? Same thing for the range. We can't actually have 0 as a y because, well, 1 divided by something can't be 0, right? No matter how small or how big it gets. So in this case, the range is also y greater than 0 and y less than 0. Okay, so those are what we're working with here. This is probably the most difficult function of the bunch. Okay, and I would recommend looking this one up in Desmos just to make sure I'm not the one bamboozling you here. Okay, we are unlikely to work with rationals too much this semester, but it is just another function you may have to look out for when you continue on in your career here. All right, so let's move on to the next function. We're almost done here, so keep with it. All right, we have y equals the square root of x. Now, if you were wondering if there was a name for this function that was special or anything, it's not. It's just the square root function. Zoom in a little bit so I can write a little better. The square root family of functions. All right, let me zoom back out. All right, square root, of course, is that funky little dividing sign looking thing. Okay. And the new question to think about here is what happens if x is less than 0? Well, if it's less than 0, that means x is negative, right? Negative numbers cannot have a square root. It's simply not possible. Okay, that's where we go into imaginary numbers, which you might talk about later, if you know what I mean. Okay, but right now, we know that negative numbers don't have a square root. So when you draw the graph here, okay, you do have a point at 0, 0. Okay, let me try to make it bigger. Okay. You do have a point at 0, 0, because the square root of 0 is 0, right? But the rest of this kind of looks like this. Okay? So, this is kind of like if you took the parabola from the quadratic equations and kind of turned it over. You did some quadratic tipping, some parabola tipping. Okay? And so, here we have kind of half a parabola, but it's on its side. Now the domain, of course, we were talking about it, but it has to be x greater than or equal to 0, because you simply cannot have negative square roots. The range, however, is also limited by the same thing. Okay, as it's a function, your y has to be greater than or equal to 0. Okay, otherwise you won't really have a function. Okay, we can talk about that in a little more detail later as well. All right, so this one a little more simple than the last one. It's just kind of like if you took the parabola and you tipped it over, right? So let's go ahead and get to the last final parent function of the day. That is, of course, y equals -3. Well, you might be asking, Mr. Hu, I don't see the x. Where's the x? Tell me where the x is, right? You're trying to say, you want to find the x? Well, this one doesn't have it, okay? When your function doesn't have an x, but it does have a y, we do have a term for these functions. It is called the constant function. Oops. Constant function. Okay. Let's zoom back out for that. All right. That is because this kind of graph does not change the value of y for any value of x. So if x is 0, well, y is -3, right? If x is 5, y is -3, right? It didn't change. I mean, the function says it shouldn't, so why should I change it? All right. So for this specific example, the specific parent function, okay, it just looks like a nice, straight, flat line. Okay. I guess you could say that this is kind of like the linear because it is a line. Okay. It should be in that family, but the difference is that this line is got no slope. You're not going up or down, and so that's why we have a separate saying. This is a constant function. Okay, and so when we talk about domain and range, well, you can pick any x. It has no bearing on what the y is, so this would be all real numbers. Okay, but for the range, we're limited by this y equals -3. So in this case, the range would just be y is -3. Okay, you can't be anything other than -3 in this function, right? So that's how it's got to be. All right, so let's go ahead and continue here. A couple of little examples I want you to try at the end of this video to try and get your mind working so that when you come to class, you have an idea of what we would like you to do. So, all right, so here I have a bunch of little graphs, okay, and I need you to identify them all, okay? There are a couple exceptions if you follow the directions up here. We're not talking about any exponential stuff, so you don't have to worry about that. And instead of a reciprocal, remember we called this the rational function. So if I can actually get it to the right, rational function. Okay, so please identify the functions here. Okay, I blocked out one of them. That one was the exponential. We're not talking about on this time. Okay, but using what your notes have, okay, you can even go back and search through the video, figure out what each of these functions represents the parent function, right? Okay, I'll give you a second. Pause the video, please. Alright, and so hopefully you gotta try that one out for yourself here. Okay, and I'll go ahead and write out what each of these are. This one should be the absolute value. Okay. This one is the square root, or squirt. Okay. Out here. This one is the constant. My picture's in the way, sorry guys. That one's the constant function. Okay. This one is the cubic. We've got linear. Oops. Okay. We've got rational. And then we have our favorite here, quadratic. Kind of ran out of space there, but hopefully you were able to give that a shot and test your parent function knowledge. Okay, and let's move on to our next little set of exercises. All right, final set of exercises here. This is identifying parents from your functions. Okay, now these are just general functions. Okay, just kind of examples, and the reason we learn parents is so we can identify what their family members might look like just based off the parent. Okay, so I'll give you a couple of minutes. Pause the video, okay? I'd like you to figure out, or I try to identify what these functions are, or what kind of parents they have, okay? So please classify them using the names, okay? So if I were to think, oh, this is maybe an absolute value function, I would write this absolute value function, okay? Go ahead and try it. Okay, so hopefully you paused and gave yourself a chance to try it yourself, okay? If you're not so sure, go ahead and follow along with me for the answers. And if you have any questions, you have a chance to include those in the bell work during class. All right. So first of all, we have 2x plus 4. Okay. You might remember mx plus b as a form. Okay. We talk about this a lot in Algebra 1. This, of course, represents a linear function. Okay. Linear function there. All right. Next one, we have an x squared. So this one looks a lot like our friend, the quadratic. It should have a parabola for its shape, excuse me. Okay. And then the following two, well, this one's got a fraction bar, and out of all the ones we talked about, only the rational functions have a fraction bar. All right. And the last one, of course, has a square root sign in it, so that is the square root. I'm going to call it squirt. You are free to kind of shorten it like that as well. That is totally acceptable by me. Okay. Square root function there. All right. So hopefully you guys got a chance to take a look at all this stuff. Oh, I kind of blocked quadratic, didn't I? Oh well, quadratic there. So there you are. All right. For a first time teaching you by video, I hope you guys enjoyed. Okay. You do have to watch the video in order to be prepared for classes. So hopefully you took the time out of your day to watch this relatively shortish video, or skipped around, hopefully, at least. come to class prepared to, engage in this kind of content when we come back. All right. I will see you guys later.